These look like standard Avid 1 and Avid 2 production knife boxes from Vero Engineering. But these letters RP1, handwritten on the box, tell the different story. Most of the time on this channel, I review production knives exactly as they come from the factory. What happens if the designer himself takes a finished piece back to the grinder? Today we're looking at Vero Engineering Avid series, specifically the Avid 1 drop point and a very special Avid 2 RP1 that Joseph Vero personally reprofiled. In a few seconds, I'll let Joe Vero, the designer of the knife, to talk about this knife himself. And then we will explore the quality of the build as well as look into hardness of both blades, as we do on this channel, remorselessly and without bias. And so let's talk about what makes these knives unique, at least in my view. The liners are skeletonized, and you can clearly see this on semi-transparent or mostly opaque G10. You can see the internals of the frame right there. I'm not sure if I'll have time for full disassembly of this knife, so here you go. Hardware is Torx T8 all around. Am I leaving anything out? Oh, the titanium on the liners, in case you wonder, is the highest grade commercially available 6AI4V. Good choice. OEM for both of these knives is Bestech, and Bestech heat treats are some of the best in the industry. But that is subject to verification. Vero Engineering runs chats on Whatnot auction site, and I use this opportunity to ask Joseph how he started in this business. Here's his response.
Of 2019 blade show, and it was essentially this knife right here with a Tonto blade, so slightly different than this. Then 6 years later, I was handed the award for best folding knife in that same lobby. So full circle, craziest thing ever happened to me, and that award was for the Avid 1. So the drop point version of this. I've been collecting knives for years and years and years. How I started is, like most people, I bought a PM2 and I sharpened it and cleaned it up and used our home dryer with rocks in a tube and tumbled it, as we are wont to do. Sold it for a little bit more, worked my way up, and here we are.
Okay, and on the flip side of that, someone said run auctions faster.
Run auctions faster, let's go.
If you're wondering why this Avid 2 looks so different from the one depicted on the box, the answer is in those letters. Oh, and in the signature on the blade. You see, when Vero Engineering gets a batch of knives in, sometimes Joe handpicks some of the best functioning knives and then does some experimental modifications to them. These may or may not end up in production later, at least as a small batch, which makes this example very collectible, effectively doubling its value. Looks like he might have changed the primary bevel grind angle. Looks like he's shooting for a much sliceier blade geometry. Alright, on the standard Avid, and it should be the same between Avid 1 and Avid 2, the behind the edge thickness is about 19 thousandths of an inch. The reason I can say that they're similar between the two models from production standpoint is the grinds come to about the same line on the blade. Here we have, let's see, we have 13 thousandths of an inch on this blade. So the primary bevel angle looks a little more acute than in a production knife, reaching closer to the spine. This knife theoretically should slice better than this production version. But let's test this theory. Here's a piece of regular packaging cardboard secured to my bench top. It's as flat as I could find it, and here's my Newton meter. I'm going to use it to measure how much pressure does it take to slice through the cardboard using both of these blades. I'm going to set it to newtons and I'll convert it to pounds of force for you guys. It'll be on the screen. The meter is set to hold the peak value right there. So when I stop pressing, it stops at that value. You will be able to see the screen after I do each test. And here we go, I'm pressing it in. The edge of a cardboard is slightly compressed, so I'm having difficulties cutting through it. I got 32.4 newtons, but I am not so sure how clean this experiment was. Let's try it with a reground blade. And same idea here. I'm spacing them apart so there's no interference from any cardboard deformation that occurred from the first cut. Again, having difficulties cutting through. I got exactly the same 32.4 newtons. You know what that tells me? It tells me that I'm measuring the peak as I'm trying to break through that deformed edge of the cardboard. So what I'm going to do, I'm going to pre-score it and then measure as I'm cutting down. And this way I will be indicating the highest pressure during the actual cut. I think that would define sliciness better anyway, making sure that the incisions are of the same depth here. And so here we go, starting again with Avid 1. And I'm going to go as far as it starts free cutting. You know, it accelerates a little bit. 41.4 newtons. Let's see what we get out of Avid 2 RP1, my prized collectible possession. And here we go. It takes a second. It felt lighter and it indicated 36.3 newtons. So a 46% decrease in the behind the edge thickness gave us 13.4% decrease in cutting force. Time to take a closer look at the edge, and for that I'm using my microscope, which connects to any handheld device via USB-C port. And it comes with its own app that allows you to not only observe whatever it is you're looking at on the screen, but also record it as a photo or a video. Here's the app. You can find a link to the microscope in the description. It's very inexpensive. And magnification is varying between 35 and 50x. Over a year or so that I had it, it became an indispensable tool in my sharpening arsenal, because I can see what I'm doing with it a lot better. So I'm recording a video using the app that's on the left and slightly enlarged, and you see what's going on in the rest of the screen from using the camera on my phone. As you can see, the grind of the secondary bevel is very well done. It's pretty flat. There's some evidence of stropping. Of course, we're looking at Avid 1 first, going in chronological order here. I see no issues with the grind. Pretty consistent striations. Let's look at the apex straight in. Ooh, I see a little bit of wear. We're looking at the belly area of the blade. So potentially it was a little understroked at the factory, and that's why it's rounding off just from using it in some minor cutting tasks. Here's the tip. Tip is very well formed. It's definite like 8 or 9 out of 10. Almost no radius at the tip. Means it wasn't overstropped right there. That's what I'm talking about. Nice and flat. There's no rollover, nor would I say it was overstropped. Maybe a little even understropped. We'll look at the Avid 2 next, and I have no idea whether Joseph reground the secondary bevel or is it a factory bevel, but it's beautifully done. Look at the striation direction. Will be perfect for cutting. And look at the apex, almost an invisible line there in the middle, meaning it was not only well formed but also well stropped. There's no burr rolling over. Oh, and this is the satin finish that he ground into the primary bevel. And here's the tip. That is simply put perfect. 10 out of 10 tip is simply put perfect. 10 out of 10 for sure. Almost no radius visible, even under the microscope. And the secondary bevel angle seems to be consistent throughout the entire length of the blade. Did he do it, or is it factory? If you like this grind, please hit the like button so that the world and Joseph Vero know that you care. I am still curious about Avid 1. Full disclosure, I purchased it in the secondary market, but it was advertised as not carried, not used. So I would like to inspect the apex and the other area of the blade, and indeed I see that the apex is very finely formed, but there is definitely evidence of use. draw your own conclusions. Why am I considering Bestech one of the best knife OEMs or original equipment manufacturers in the world? You've probably seen the video about this swordfish, and it also has accolades of being one of the most budget knives with a MagnaCut blade on the market. Not only that, but my tests show that this blade is right at 63.5 HRC, which is an incredibly good heat treat for MagnaCut. One might say, well, this knife was under $100. How come this knife is barely under $200? Let's point out some of the differences, and we'll roll the Avid 2 into this comparison as well. First and foremost, while the MagnaCut typically costs more than S45EN just due to its initial scarcity, this situation has changed drastically because now Aerosteel is producing MagnaCut in pretty much unlimited quantities available all around the world. And there are no more US to China tariffs involved. That means companies possibly transferring savings right back to your pocket. Another thing, if you notice, there's only one method of deployment for the swordfish, which is the flipper tab. You have numerous ways to deploy this blade. You have a front flip, thumb flick, and you have fullers on both sides allowing for spidey flick as well as a regular thumb flick, although that last one requires a little bit of effort. And of course, swordfish has stainless liners as opposed to titanium. What changed from Avid 1 to Avid 2? The most obvious, other than the blade shape, it changes. There's a single screw that retains this immense spacer, and there's a double screw here. Why is it important to understand how the spacers work? You see the smoothness of how the knife runs, and these run extremely smooth. You will not find a better action on any knife. The reason they run so smooth is parallelity between these slabs on the liner or frame. The more parallel it is, the better bearings engage the recessed surfaces there, and the smoother they run. So you can put the most expensive bearing into a knife that does not preserve this parallelity between the slabs, and it will run jittery. Now, is this a smooth knife? Yes. But I can feel and hear the bearings rolling when I operate it. It's hard to hear on camera, but let me try. Let me bring the microphone here. You heard that, right? So improvements of that nature cost money. That's why the price difference. And of course, some amount of the overall cost to you goes directly to Joseph Vero and his small company of family members that work with or for him. I'm not sure which, or he works for them. Maybe that's the case. But let him talk about that.
If you knew what you know now about the knife business, what I've done differently at the beginning? So many things. So many things. There's yeah, it's one of those things where you try not to have regrets on things, doing things differently and stuff, but the amount of things that I've learned up to this point, hand off stuff, I try to do too much myself for a long period of time. Like Dimmer said, hire her earlier. She's been a huge help. Hire more family. Dude, my dad worked with me, my sister worked with me. We've sent things home with my mom, and she's like that bead with that knot. My mom probably tied that knot. My mother-in-law, my kids have been in reels. So yeah, we got family. That's the one thing I learned. Utilize what do they call it? Monopolize family, utilize them. Take advantage of your family.
What's that village? Takes a village.
It takes a village to run a EDC company.
All right, guys, as you can see, I fully disassembled Avid 1 and only removed the blade from Avid 2. Quick observation, as you can see, these are very basic, not particularly expensive bearings, none of the double row solid brass or anything like that. And that just goes to support my statement earlier. The parallelity of the handle is more important than the bearing itself, because This knife is a living proof. You saw how silky smooth the action was. Silky is the word I prefer to use, actually. A lot of people overuse the word hydraulic. This is not hydraulic, it's silky smooth, almost no resistance felt, because this immense spacer creates that parallelity. Check this out. So we're going to measure here, 166 thousandths of an inch, and we're going to measure here, 1,000th of an inch difference. Let me double check. 0.5 thousandth of an inch difference. So on a 3.5 inch span, that's a very decent tolerance. Very decent tolerance. And that's why the knives are running as smoothly as they are. Okay, another thing here is look at how well designed all this is. Radii at the corners of the spring recess here. That will reduce the amount of stress building up in these corners. Very properly designed. Washers to protect titanium from the bearings are probably, oh, they're ceramic ball bearings. So it's a little bit of an upgrade. So these are ceramic ball bearings. And that's why they put these probably hardened washers. They're too thin for me to test. But what I will test, which is not something I normally do, is the engagement plate. That's what engages the blade. It sits in here. That's a detent ball there, and it engages the back of the blade. Where is it? This is your engagement surface. So we're going to find out how hard that is and compare it to the blade hardness and draw conclusions from there. Now I'm going to poke this 3 times as I usually do. I'm only going to poke this 3 times if there's something weird about the test on the coated blade. These black parts are all PVD coated according to my research. Typically that process reduces hardness by as much as 2 points HRC. I am very negative about PVD and Cerakote on blades. So if this comes up to good hardness for S45EN, which we'll talk about during the test, I will only poke this one. If this hardness is way off, I'll have to poke it 3 times. I fully realize that it may reduce collectability of this hand ground blade. On the other hand, of course, if my channel hits 1 million subscribers one day, adding my hardness test will only increase the collector's value. So if you're not a subscriber yet, please help me get there. Subscribe now and hit that like button while you're at it. Is there anything I'm forgetting? Oh yeah, I do want to point out the hardware, except for the pivot hardware, all the other screws are titanium, and the spacers, pins, and so forth are stainless steel. So, and another thing I want to point out, which also goes in parallel with the discussion about parallelity, check out, I brought this flat plate here to show you. Listen to this. Nothing, right? No rocking. It's flat. So this flatness and this parallelity are critical, absolutely critical to how the knife feels when you manipulate it. Great design, and speaking of it, is it Joseph or Bestech engineers who done it? I asked him in a chat.
Do I design the mechanism or just the overall design? It depends. So for the first knife that I designed the geometry for the mechanism and everything. And for the most part, I work with the manufacturer now to tailor the geometry to their machining capabilities and how they feel like it should be. So we work back and forth on that. For instance, on these, it's a liner lock, and it's a very specific geometry because the flipper tab is here, which is where most of the time your lock face is interfacing with right about there. But because we have that, we have to go behind it. So we worked on that together.
I verify calibration of my hardness tester before every single hardness test. And for that, I'm using this independently certified, calibrated to 62 HRC and serialized calibration block. This segment will be continuous, uninterrupted, and accelerated 2x for your time's sake. The reason it is continuous is so that you know there's no behind-the-scenes shenanigans. Basically, what you see is what I get on this dial. If you watch several of my hardness tests, you will realize that this tester calibrates between 62 and 62.3 HRC every time. And as you can see, I got exactly 62.0 on the dial. This is not an industry standard test, however, because I'm only testing one sample out of a batch of many. So yours may be harder or softer than mine. And we're starting with the Avid 1 coated blade. PVD stands for particle vapor deposition or plasma vapor deposition, used interchangeably by folks in the trade. What I call it is not as important as the fact that the blade is subjected to 350 Fahrenheit temperature for about 2 hours. And here comes our first poke result, 59.8 HRC. Is this okay? Is this not okay? Here's what I think. I believe at this hardness, the toughness will improve minimally, while the edge retention will slide a little bit toward that of S35VN. Maybe a little bit higher, somewhere in the Vanax edge retention territory. Let us not jump to any conclusions yet and wait for the average result. For this poke, the result was 60 HRC exactly. Here's why I'm beating a drum against PVD, or for that matter Cerakoting. Exposing the blade to such high temperature for hours acts as a tertiary tempering cycle. Not every company has ability and foresight to plan for it. The edge on an overtempered blade will roll over faster, it will dull faster, and it will bend easily when subjected to side loads. 59.7 HRC on the third poke gives us 59.8 average. We are definitely in the acceptable range for this steel. The question to my viewers is, would you accept a slight performance degradation to get blackout coating on the blade? Moving on to the next generation Avid 2 blade that was reground by Joseph Vero himself. I don't think he ever mentioned reheat treating the blades, but I will ask him just in case. Pardon me for dropping another big name. Dr. Laren Thomas compiled the tables based on the ideal heat treats he developed for each steel, or using the data from similarly perfect heat treats. 61.8 HRC, but let us not celebrate until we see the average result for all three pokes. 61 to 63 is what custom makers select for S45VN. Why, you ask? Because at this hardness, the edge retention will be maximized without much of a reduction in toughness of the blade, and without any noticeable reduction in corrosion resistance. Only a very good manufacturing company would plan their heat treat activities to accommodate the coating. 61.5 HRC on this poke. So we're in the zone there. What is the challenge? Say a company would like to make 500 blades and 200 of them will be coated. Cerakote or PVD will yield up to 2 points drop in hardness. DLC coating may be half a point to a point drop in hardness. Because it's not feasible to segregate the blades prior to completion of thermal cycle, a company should target the highest possible heat treat range so that the coated blades don't end up below the required range. 61.2 HRC for this poke, and the average is 61.5 HRC for the uncoated blade. And as I promised, now I'm going to attempt to measure hardness of the log bar plate. I say attempt because it's very hard to find a good spot to poke on such a tiny part. So without a whole slew of data, it's hard to predict how long this plate will last. All we know, it needs to wear out faster than the blade itself, because you don't want to sacrifice the blade, you want to sacrifice a replaceable piece. Although in my entire knife collecting career, I've only seen CKF, or we, who makes the knives for them, provide a spare log bar plate. Well, also we have no idea what steel is the plate made out of. But we got 43.5 HRC on this poke. I'm trying to examine whether or not the poke was far enough from any edge to be a legible result. And I see that it's a little too close, and, you know, to be honest with you, I don't know if I can get the right spacing on a part that small. And yet, I am going to poke it again just to see if there's any kind of consistency. Like I said earlier, this is not an industry standard test. Furthermore, we don't know what steel this is, so we don't know what the right looks like. Well, I know the steel is martensitic because the plate is magnetic. And with this poke coming in at 44.2, I'm going to make an educated guess that this is 400 series steel that has been machined or stamped out of a cold rolled plate and not heat treated thereafter. Anybody with experience in knife making, please comment what do you think about this. Clearly this log bar plate is meant to be a sacrificial piece, the piece that wears out rather than the blade. And I expect that Vero Engineer wants you to send the knives back to them for a repair if you end up wearing the plate all the way down to nothing, where it completely not engages the blade and vertical rocking occurs. As it stands now on the new knife, the engagement on Avid 1 is perfect, 40-60, 60% on the locking bar, 40% on the blade. On Avid 1, it's more of a 50-50 engagement.